Hello and welcome everyone to today's webinar. I'm Gustav Kagesen, Science Director of Hub Ocean, and we'll hang on for a minute or so to let a few more people join. If you see people that you know, please feel free to say hi. Hi, Chris. Oh, you're on mute. Sorry for those just joined. We're waiting a minute or two. So feel free to say hi.
Yeah, good morning, Gustav.
Good morning.
Hey, Steve, what's up?
Hey, Antonio, good to see you.
Okay, I'll get this webinar started. So we have a bit to cover. So hopefully by when we get to the meat of it, everyone will be here. Okay, so welcome everyone. Today we're gonna go have a look at the Ocean Data Platform, talk about corals. We'll have Steve join us from TNC to tell us a bit about his work. And it's me and my colleague Brian Free from Hub Ocean. Let me share my screen. There we go. All right. So this webinar is part of a small series we got where we are focusing on some of the valuable habitat data, really at the global scale, working to connect what's available already on ready to consume global maps down to the local scale. And so the problem we're really trying to address here is how do we make the most out of all of the information already collected? And I think for all of you that work spatially, that can be quite tricky with different mapping units and data silos and all of this. So we'll do a bit of a showcase of how that looks like on Ocean Data Platform, and by the end of it, we'll have some room for discussions, and I've got a couple of poll questions that I'd love you to stay around for. The flow of today looks something like this. So I'm just going to do a very short intro of who Hub Ocean is. We'll hand over to Steve for his presentation of his work, and then we'll go on a live demo on the Ocean Data Catalog and the data we already have on there. Then we'll have a look at the My Data space that we have for all the users, and then we'll do a little data crunching demo, how we can add maps together before we go on to questions. And so Hub Ocean, we are a nonprofit ocean tech foundation based out of Norway, but working globally. And we also have a sister company called Rev Ocean. They built a hell of a research vessel, and next year when it starts to be operational, will be the data hub for that. But in the last 6 years or so that it's taken to build this vessel, we've been sort of hard at work at building the Ocean Data Platform and try to make it meaningful for science users, and yeah, so that's what we'll look at today. The Ocean Data Platform has, it's fairly new, but we've got a pretty good uptake around the world with users. So it's just a snapshot of who's using it right now. Norway is number 1, followed by the US in terms of people. So the shiny machine that we built, it has an open data catalog. It has your own data space. It's API based, so we can serve as a powerful backend to other tools as well. We do host workspaces. We'll have a look at those today. but you can also connect from other places like Google Colab or your local environment. And it's also built for JS integrations as well, so you can connect to QGIS and ArcGIS. Nothing I will demo in detail today, but there's plenty of documentation and videos out there. So if you're keen to get started, I strongly encourage you to just sign up, because then you'll have access to all of this. It's a free sign up, and you can use the QR code there, or just Google us. App.habocean.earth is where you find the platform. And if you want to know more about this, just head over to our website, www.habocean.earth, and there's a pretty good about section as well, where you can see a bit more about us. There's any questions you might have is hopefully answered there, and you can see all of us on the team. With that, I'm going to hand over to Steve.
Okay. Thanks, Gustav. Good to be with everybody. I am going to talk a little bit about what the Nature Conservancy has done to work on developing benthic habitats around the Caribbean region. I am the Director of Science and Strategy for the Caribbean Division. And if you're not familiar with the Nature Conservancy, we're a global environmental nonprofit organization, and we've been around for 75 years. We're just celebrating our 75th anniversary. And our mission is to conserve the lands and waters on which all life depends. So we envision a world where there's diversity of life and people and nature thriving together. And we recognize that healthy ecosystems are essential for food, water, and climate stability. And so the things that we work on are things like protecting lands and ocean ecosystems. We use a lot of science and data to guide our decisions. And we work very closely with governments, communities, businesses, tackling things like climate change and biodiversity loss. So really challenging issues in our world. And in the Caribbean, we have 7 offices, and we work in about 17 countries and territories. And our strategies are specifically focusing on oceans, so looking at expanding marine protected areas and strengthening management within these protected areas, helping countries get to their 30 by 30 goals. And a lot of our ocean data helps support those decisions. We integrate a lot of these data sets into systematic conservation planning frameworks like MarkSAN to try to identify the scenarios and the spatial allocation of 30%. One of the countries, 2 of the countries we're working on right now is Barbados. So we're working with the government to help support their ambition to declare 30%, and to do that over a period of about 10 years. And we also are working in Bahamas, but in the Bahamas, it's more focused on strengthening management within their existing protected areas. And so lots of work to do there. We also try to strengthen resilience to climate change through nature-based adaptations to support sustainable fisheries and livelihoods. But underneath all of this is the science and the data and tools to guide the decisions. So all of the information on the work that we do can be found at that URL that I just posted in there, caribbeanscienceatlas.tnc.org. And what I want to talk about today, in the time that I have, is a little bit about our Caribbean marine maps. And we've been working at developing benthic products for about 20 years now. And we use a multi-scale mapping approach. So a lot of the projects that we're working on, it depends on the scale. We do regional projects, we do national projects, we do local projects. And depending on our project, we'll use a different approach, a different scale. So the region-wide benthic habitat maps that were finished in 2021, those all came from planet imagery. And I'm going to put a link to that article that talks about the regional data set that we created. And the reason why we wanted to develop a regional benthic map was because we're answering regional questions, and the Caribbean is extremely connected. These ocean currents serve as conveyor belts of biodiversity, and we wanted to bring together as much information at a consistent scale to be able to answer regional questions, since a lot of these countries and territories are operating independently within their own jurisdiction. We wanted to supplement their efforts with a regional data set. And so what we did was we worked with Planet to develop, this process took about 2 years to develop a consistent mosaic using the original Planet Dove satellite constellation. And we spent a year identifying which scenes were the most appropriate in terms of the ability to see through the water column, looking at turbidity, looking at sun glint. We wanted to identify over 35,000 scenes that were brought together, and then working with Planet to mosaic those scenes. This started in 2017. And that took us 2 years to complete this mosaic. Then we also at the same time developed a geomorphic zone. So looking at the reef crest, looking at the fore and back reef. And a lot of that was manually digitized using high resolution satellite imagery. We also modeled depth using the Planet imagery, and also working with Arizona State University, developing those depth classes, because that was very important for our classification of our marine data sets. And then another component was a lot of field data. So we had over 5,000 drop cam videos that were collected. And this was over the period of about 10 years. And it was in different locations around the Caribbean. And integrate that in developing a rule set using e-cognition to be able to map these 13 classes. So the important parts that came together to develop these regional benthic maps included developing the best image we could find, developing the geomorphic zones across the region at a consistent scale, developing the depth classes, and then finally integrating all the field data to come up with a rule set that we use to classify this huge amount of data. And then after that, we took about 6 months to manually clean up areas, look at each class specifically and clean up areas that we knew were obvious, and then work also with local partners. And all that has been described in that paper. So this was a milestone product that we released in 2021, and we've made it available on our website. I'm going to put this website in here, caribbeanmaps.tnc.org. And we continue to do additional mapping work at national and local scales. We're using a lot of drones to monitor reefs. We're using drop cams. We're doing a lot of in-water surveys. We have floating platforms that we connect to cameras that are that are connected to a GNSS receiver that we then PPK correct. And so we're able to take our in-water photos and align that very closely with our drone imagery, which is at the centimeter level. We recently finished a national map of benthic habitats for Jamaica. And it's interesting the improvement in accuracy once you go from a regional scale to a national scale when you have more opportunity to collect field data. And in the original regional maps, we estimated about 42,000 hectare of seagrass. But then when we went in and did national scale surveys across the island, and we used updated satellite imagery with using the SuperDove constellation, our ability to estimate seagrass, for example, was we discovered a lot more seagrass than we originally thought. And that went from 42,000 to 55,000. There was a lot more seagrass on the southern end of the island that got confused with macroalgae that was in reality seagrass. And so as you do these exercises, it's interesting the patterns that you find, and your ability to map obviously increases in accuracy with more field data and with better satellite imagery. One other thing I want to mention is that the coral products that we developed at the regional scale were used to develop a coral climate refugia model. And that is being used in a project called Coral Carib. There's the link to that article that talks about the development of that coral climate refugia, which tries to answer the question based on coral larvae models that we've run in the past, based on thermal regimes, looking at chronic thermal temperatures over time, and also looking at hurricane intensity. Where are the areas where we anticipate that coral will persist at a higher degree into the future, given the climate scenarios? So that information went into developing and identifying areas across 4 countries, Cuba, Jamaica, the DR, and Haiti, looking at where we can work locally to be able to help coral persist into the future. And so lots of outputs came out of this work. It's going into marine spatial plans. We've done a lot of work with the deep ocean. If you go to this page right here, you can find out about our 30 by 30 work, how we're working with countries to identify important areas to protect across not only marine, but also terrestrial and freshwater. And a lot of that, the coral habitats that we developed were put into this model to identify important marine areas. And we're also working on deep ocean habitats and modeling those using things like bathymetry and substrate, trying to identify the important habitats that go beyond our ability to see through the water column from space. So a lot of exciting things that are going on, and we're trying to support the 30 by 30 goals and develop an open GIS data product, be able to share our data when we can. And we're thankful to work with Ocean Hub on this and provide another way to get our data out there. So with that, I think I've taken up my time, and I'll pass it over to Gustav.
Thank you so much, Steve. I think, yeah, thank you for all the hard work you're doing, and hopefully it's going to be good for everyone to just keep this in mind as we're sort of diving into the platform and the data that sits there. And then we'll come to wrap it all up. I've got lots of questions for you, but I'll save them. All right, so let me go back to sharing. There we go. All right, so Ocean Data Platform, we'll just dive right into a bit of a live demo. When you're signed in, this is what you see. If you're not signed in, your My Data space and the workspaces are grayed out, and you can just access the metadata without download. But everyone who's signed in, you can access all the data in open formats, and you have access to your own data space and the workspaces. And yeah, so I'll just head over to our data catalog first. And this one is obviously built on the back of Giants. It contains lots of different open data sources, for example, from NOAA and many others, which we are incredibly grateful for. It also does include, for example, some industry data that we worked hard to get the industry to share back to science, and some unique data. So we do create DOIs, for example, and publish unique data sets, as well as bringing in open data sets that we think are useful. Yeah, the basics of it, you can search spatially, and you can search thematically. It contains essentially two main types of data at the moment. It's either just a collection of raw files with file metadata that could include, for example, sonar files, photos, you name it. But we also have a built-in support for vector data, and rasters and gridded data is coming next. Currently, they are just available as files on the platform. But for vector data, as this example, this is a global data set of marine protected areas. We'll jump over to coral reef in a second. It's quite useful and it's quite large. So you find the ID for that data to connect to it. You can also connect to it through GIS with OGC features or vector tiles. And I'll show you more about vector tiles as we go through the coral maps. So you can already here see what is this data about, how many columns, how many rows. If it's been supplied, there could be additional information about its category, and you can have an idea what's inside that data. So we provide some summary statistics. There can also be additional files, and some of them will have previews like PDFs and text files. If we hit this explore map, this is actually the vector tile functionality. It allows you to see all of the data and then zoom in. We're going to look at the Caribbean today, so there are some of the marine protected areas in the Caribbean. This is still a beta functionality, so for very large data sets, it can be still a bit funny. For example, one we'll look at next. Yeah, if it's very large polygons, it is a bit challenging. Okay, so we'll do a little search for the Caribbean, see what we find. Sort of the larger bounding box that I made for today looks something like this. And we'll add coral. So what first comes up here is for example, Island Coral Atlas. And Island Coral Atlas obviously they have a very nice interface. I think they build a website. You can download it. You can look at the data. But of course, to combine this data with other data, you have to bring it somewhere else. So it's this is one way to access it. Here we have the full data. We can have a look at that. And some data sits in collections. Some are just data sets. So the collection is just a first way to group data. In this case, we have the map source. We also have a consolidated layer that is a bit faster to work with. When you go into the source, here you can see again what it contains. It has 40 million rows in this case. We also made available the raw files. There could be reports in here and other supporting information. I'm not going to go inside that right now to save us some time, but we're going to remember that, and we can bring the ID with us for additional work. So another data set that comes up in the Caribbean. Well, actually, here's more local data set example. This one comes from NOAA. I saw a couple of the NOAA folks on the call who was part of this work, and so was actually I, if you look closely there. So NOAA made their data available quite nicely as well in a big hub with all of the work that's there, and we're thankful for it being open. And we have also made quite a bit of that data available on the Ocean Data Platform. Again, you can go inside that data. You can read a bit about what's in it, and we can go and explore table. Actually, let's go ahead and do that. So when you go to explore table, you go inside the actual data, which is I think it can be quite nice to start exploring a data set without programmatically accessing it, which you can also do. You only see the first 1,000 rows, but then you can filter the data and look at specific areas. So if we go in around Calabria, for example, we can create a spatial filter around an area we want to look at. We could even add a filter based on any of the columns. Let's say we want to look at, let's look what's in here. We want to look at only coral reefs. We apply that filter and that's the data you get. Again, this was the kind of data that's using object-based image analysis, so it's fairly large. There's a little trick you can play. Oh, that's going to be made available for all in a second, but if you remember that link, you can use it. So we can look at a lot more data directly on the platform too. And we can give it a bit of color if we want. I just got hold of 86,000 polygons. I think my spatial filter disappeared. Let's see if it works. Give it color. Look at that. Okay, actually we actually got the whole map because I did this out of order, but it worked. So it's a pretty fast cloud-based access because the way we've indexed this data. So here you can go in and see all of those polygons, but we could also been making an additional filter effort. For example, let's try the coral reef again. Yeah, anyway, so this is a way to start exploring a lot of sources of data and see what's in it. Let's see if this works. Here's all of the polygons that has been indicated to be including coral reefs. Okay, so you can go on and look for data in the catalog, and specifically for some of these sort of high valuable habitats like coral reefs and seagrasses, we have put some effort in to make quite a lot of data available. And another one I'll show quickly. So from WCMC, which is a commonly used global data set for more global analysis. And here you can see there's also a bunch of supporting information that we can have a look at. And in the same way, we can explore and look at that data. However, we don't have all of the world's data in the catalog. So either you want to come here and find some useful data that we've already made available, but you may also either have data that we haven't made available that is open, or you have your own data that you want to work in. And so then you can create your own collections and add new data sets. Creating collection is fairly simple. Just create a name and a description, and you've made a collection, and you can then manage access to that collection. So now if you know other users on the platform, you simply set up admin editors and viewers. Then you can add data sets and write something coral, very exciting description. So Now that you made a data set, this is just sort of a landing page for that, where you can add data and metadata, and you can again manage access. And the addition here is you can then hit the public sharing, which doesn't list it anywhere, but it makes it open to find. So again, it's going to be then downloadable for anybody with this link that has a user account, and the metadata is open for anyone. Now, if you created something that you have the right to share, or it has an open license, for example, a CC BY license, then you can also then request to publish it. And we will just double check that, we have the right to put that on the platform. And if there's any missing information, we'll ask you for it, but otherwise it's going to be published. So we try to curate, but just to ensure we're building the basic requirements. And actually, to show that in more depth, I'm going to hand over to Brian for a second.
Hi, thank you everyone for joining. And yeah, I'm gonna show you sort of two different ways of being able to upload data to the platform. Because we know some of you all prefer to have maybe a programmatic lens. I'm going to show it in using R, and then others may want to use it as software. So we're going to first just work with data that are not up on the platform. And so there's this one for the British Virgin Islands. I've already downloaded it, but you can download as a GeoJSON. The platform is really optimized for GeoJSON, CSVs, and one other type of format. Right now, you cannot do shapefiles, so that's why I'm going to use the GeoJSONs. And then we can come over and we've created this data collection that Gustav and I have access to. And we've created a template for the data set for this BVI seabed classification. So then we can switch over and you can get it within your QGIS system. I've converted it to WGS 84. That's what the platform is going to work with for the CRS. So then we can just drag and drop those data straight into the platform, or you can navigate towards it. And so now you've told it that this is the file that you want to be uploading. And so you can upload the file. This one's not very large. It's 42 megabytes. And so it's pretty quick. So now the data are uploaded. Gustav had shown that there are times you could explore data tables. And so you just need to be able to ingest that table to become part of the data set that you've created. And I've already added some of this description and other components. And so then we can explore this table. And it's going to look a little bit different right now. But then you can also edit the table. And what we've talked about, or Gustav has talked about, of like trying to make things really fast, is that you can index different data sets or different factors. And so we've just indexed the geometry column. So that is one way of doing it. And then you would be able to manage access. As we know, is you all want to be working with partnerships and collaborations. And so having others to be able to gain access. And this also will allow people to be able to use this UUID, which is going to be helpful for when we switch over to R and being able to then have R and RStudio talk to the platform. So I'm not going to go over all of the code. I'm just going to show how this works. So I'm just going to go back one step and then show that this is a data set. Right now, it's completely empty. But we're going to work with the exact same data. So I've taken this UUID and I've added it to this code, and it's going to be down here. And basically what this does is it loads the data, creates a schema that will then get populated with the data set, and then pushes it to the platform. Again, I can share this code and we can talk about sort of the actual semantics, but I just wanted to show how this can talk to the platform. And so you don't actually really have to leave RStudio to be able to talk to the platform, download, transform, and then re-upload so that all of your colleagues and other partners can gain access to it. So this is just making sure that I can actually use the platform, and that is correct. And then we come back here, and then in just a little bit, it's been finished. And so now if we reload this page, we can now see that this platform or the data set is in fact here, and it's the exact same ones, and we can re-examine it. So this is the power of the platform and being able to work with it programmatically. You can use Python or you could use R. I just wanted to show R. And if you have any further questions, please feel free to reach out to me.
Thank you, Brian. Bravely done there with the live demo. Great that it worked. Okay, so I just want to say also on the documentation piece, so we have yeah, a fairly good documentation page. There's the GitHub as well with examples, and we'll add these examples that we're showing. Just give us a chance to clean up some of the late night work. But yeah, so you have documentation on how you get data onto ODP. We have throughout documentation about the SDK. That's sort of the package that lets you talk easily with the platform through R or Python. And then you can see the read and write, as well as some of the actual processing work you can do on the server side of the platform, which I will demo in a bit. There's also a Stack API in order to have an open standards to search the data. And we connect with both OGC features and vector tiles on the QGIS and ArcGIS part. Okay, good. So yeah, and maybe I'll just make one more point. When we prepped a bit with Steve, he mentioned some of the data being open, and we've been working a bit with this data that TNC has already published, like here. But some data, again, may not be ready to be open, or need to have another level of control. So again, on the platform, what we put in the open catalog is generally when data can be made open, but then we have this ability to still collaborate on data through the My Data space, so that we can sort of start breaking down silos when they're not needed. Great. Okay, so I'm going to show you something that we started already yesterday when we did a Coral demo with Chris Rolfsma in Australia. And it's how we can bring lots of different maps together and solve some of the problems of making sort of best available data put to work. And we already did some work on this last year, where we used sort of the server-side features of the platform to allow aggregations on hexagon levels. So this is a prototype. It's a bit old by now, but we put together lots of different habitat data on the global scale, and we said, is there a coral reef habitat inside this hexagon? Here, this is data from WCMC, UNEP, Global Coral Map, as well as Allen Coral Atlas. So you can see here, we've done that in multi-resolution. You can see some of the underlying data. And we made a gap map as well, where we thought there could be corals, but there was no maps available. Okay, so this is one way to start aggregating data on management units, perhaps in a cumulative impact assessment or marine spatial planning sort of tool. So we'll head over to our workspaces and see how we could actually do this for corals in the Caribbean. So when you hit workspace, you'll have a few options, and we have sort of a small compute environment available for anyone in our Jupyter Lab environment. If you ask us kindly, we can make more compute available, and it's the cloud, so obviously you can do Dask clusters and really large compute jobs in there too. So I've already opened my environment, and I chose the Jupyter GIS option, which is a sort of a beta version of a GIS that we have also in the Jupyter Lab. I'll show you in a bit what it looks like. And when you do that, you have Python, you have R, and you have this JS project option. Yeah. So what I then did, so I created some code. Again, this is Python, even though I'm more native R, just like Brian. So I connected to the platform. I actually used my API key because it's a bit more stable then, but you don't actually have to when you're in the workspace environment. You could also just write this client and you're already connected. Then I connected to the Jupyter.js, and I wasn't as brave as you, Brian, so I did prep everything to ensure we didn't get stuck somewhere. But I created a global area of interest for any great global ambitions. And then, but I thought we'll tone it down for a sec today and looking at the southern, eastern part of the Caribbean. And we have a little demo Zoom box as well to really look at a more local scale. Okay, so those are sort of our three areas that we can use to grab data from the platform and ensure we're not moving too big data. Because even if the platform is fast and the workspace sits next to it, it's in an Azure environment sitting in Europe. As soon as you move large data, it still takes time. We all know that. So we want to still be a bit mindful. And the same goes for bringing data into GIS through those, for example, the OGC features API. So I'm grabbing WCMC Global Coral Map. That one contains only coral, so I just need to filter on my area. I'm using that larger area in the Caribbean that I made. This one, let's have a look at that. And I'm cropping it, and I'm checking how many polygons are in there, and I'm adding it to this viewer, so we can have a look at that. I think it's right there, and because this is not just these polygons are not so complex, so they actually were quite fast to bring in and plot. Now, knowing that there's more data, I brought in the Allen Coral Atlas, and because now I'm just downloading the data into this workspace, so I want to be a bit careful. I only brought my little patch, this little zoomed demo box I made available. So let's zoom in there and have a look at what Allen Coral Atlas looked like. Yeah, it's limiting it at about 15 meters. So you see, we're just sort of capturing the shallow reefs. Now let's bring in some older maps from NOAA that was done with when data was still more manually digitized. So this is made by Kendall al., one of my former colleagues at NOAA, and it's mapping. It's from 2002, mapping corals in the Caribbean. Again, a bit in sort of same as WCMC, a bit more manually digitized polygons, but still valuable based on knowledge and data that penetrates a bit deeper. And then let's have a look at this map from Northeast Reserve that we just looked at before, if you remember. And this one has a much higher minimum mapping unit, capturing all of the patch reefs and actually down to 35 meters. So if we bring them all together, yeah, you'll see that, the more the merrier, essentially, especially because the high resolution map has a limited cover in area as well. Okay, great. But we might also want to bring in something like OBIS from the biodiversity observations that IC UNESCO hosts with very many collaborators and contributors. So if we bring that in, it actually sits on the Ocean Data Platform in a version that we currently just manually entertain. So it was last updated a few months back, but we're going to look at making that available with the automatic pipeline coming next. It has 250 million observations inside it, and we just query it here in the code. Let me skip all the way. I should mention, when I ran this, I also then choose how to filter the data, not just spatially, but also within the data set. So I grabbed, for example, in the Northeast Reserve, I just grabbed any of the polygons that had coral reef inside it. So obviously you need to do a bit of work and homework for every map you're working with. And the exploration tool that we have on the platform was one way, and it's actually quite useful. You can explore the data and see what's in it. So I did that here. I filtered all of these maps, and then I went and did the same for Obis, and it's actually quite quick. We can run it live again. I'm just grabbing anything with the family Cropera, and I'm cropping that to our Caribbean area, and it's going into that table with 250 million rows, filtering out what I want. Then it might take us a little bit of time, but it should finish quite soon. Okay, so this is one way then to add lots and lots of data. But then what do we do next? How do you actually create a map? They have different mapping units. They mean different things. And if you would actually try to integrate these polygons, it would be quite a complex operation. Okay, so it actually is finished. I can add that to the map. And we just added that again. So what I'm doing next, and I'll try to wrap this up pretty quickly, but I'm using the aggregation feature of the platform. Again, have a look at our documentation, and you can see how to call these. But you can choose then to aggregate data on hexagons. So this is the Uber system that has a hierarchy of hexagons on the global sort of geo-indexed set. So I chose resolution 9 in this case. It's about 0.1 square kilometer, about 300 times 300 meters. But you can go on any of the resolutions down to resolution 15, which is about 1 meter resolution. So we're calling that, and then I'm going back to call all of these maps. And now at this stage, I'm not actually downloading the data anywhere. So Brian could have been running this from his RStudio with, on low internet bandwidth in his local computer, and he would not bring these large data sets in. Instead, we're using the filter that we defined before, so spatial thematic filters, and then we are asking the platform to do a count based on the geometry, in this case, the hexagon tiles. And then we're just getting the result back. So we do the same for Alan Coral Atlas. I can, for the sake of showing how fast it is, I can run this as well. I did prep a bit, so they have already been run all of these cells. Now this is again being run for all the Caribbean, so you see it just did that. Alan Coral Atlas will take a second longer, but it's actually not too bad considering how complex those maps are. So again, doing the same operation for all of them using the same filters. And then, then we combine them using the spatial index to one map. And then I need to turn that into a spatial polygon because it's just an index at this point. So that's what this cell is doing. And then it looks like this. So here we have all of the hexagons that has a coral reef inside it. And we can see what was the source that told us there was a coral reef inside that sort of management unit or planning unit, whatever you want to use the data for. And then we're adding that to our visualization here, and let's have a look at that. So now running this code I actually created this data set and pushed it to the Ocean Data Platform. So what I did before, I just created a data set, an empty data set, and I put in the UID here. Okay, let's just actually go over to the platform and see what it looked like. So some of the work done yesterday, this is what I just did. So again, add the appropriate metadata on the data management page. Here, this is the view when you're inside, just exploring the data itself. So we can go explore that table. We can first just see the first number of rows, but I'm gonna show us all of the data instead. And I'll have go to 100,000 rows instead. Okay, good. Then we can maybe color it based on sources. So if we zoom back in, now we can see, where we found coral reefs and from what source. So some of them have, and we could color it on how many sources were there as well as an example. And we could filter on this too, of course. So now you can actually already here start building a map that could be quite useful for management. Now, we still have this problem, of course, with the minimum mapping unit and the spatial scales, but with a bit of smartness here, you could, decide to aggregate just the locate on an appropriate mapping unit that joins them all, and then maybe start aggregating on a larger management unit to see how much corals are in each area or something like that. But here now we're just doing locate. And we can also then go in and we can use this explore map feature too. And with this example, I ran this same code. I was fairly happy yesterday because I just did this example for the Australian work we did on the last webinar yesterday, and then I hit the apply to the whole globe, and this is mainly Allen Coral Atlas and WCMC data on the global scale. Haven't yet integrated actually the new data from the Caribbean, and it ran in a couple of hours, and this is actually, I think, a pretty useful map about 0.7 square kilometer resolution 8 on the hexagons. And before I hand over to questions and the final wrap up, just want to say that another feature that we can use here, that me and Brian will clean up the code for a bit and share too, is now that we've created a data set on the Ocean Data Platform, we can actually choose to add rows and columns to it. So this code will just allow you to add another map to for example, the global map. So let's say we want to collaborate, a number of us on this call or outside of this call, to build a map together. Let's say you might have sensitive data you don't want to share, but you're happy to share it at this sort of derived map unit of a certain resolution. You could push, we can collaborate, give write access to that data set, and just push the new rows and update our joint product. And of course, there's many ways to collaborate on, but that's one quite nice option, I think, to jointly work on the same data in the cloud. Okay, that's it for my demo piece. I'm gonna stop sharing for a second, and we're gonna open up for question in a sec. But so think about questions. You might already have them. Feel free to put them in the chat. I will put you through 3 sort of poll questions, and we could even start addressing questions while we do that. Hopefully this will be quite quick. Just asking you to describe with a few words how you thought this webinar was. Too fast, too complex, or whatever you want. Give us some quick feedback. It's anonymous, so you're not personally accountable. And I'll start addressing questions while you guys put that in. I see we have one from Joseph. Do you want to voice it yourself, Joseph?
Absolutely. Sorry, I've got you on two different screens, Gustav. So big fan of your work. I've talked to Joe in the past and to Martin at Revotion. So one of the things that our platform does is we've built in a RAG-based chat, so you can query data like this very simply and get like immediate kind of insights. Are you building RAG into this? The demo was great, but I'm just curious if you're making it for both expert users, which clearly you are, but also for novice users.
Yeah, that's the plan, right? So we want to make the platform. That's why we spent so much energy currently on the redesign of the front end as well, to ensure it's really for everyone, no coders or coders alike. And obviously AI is a huge thing coming, already helping, break down barriers to access things programmatically, but also sort of the one prompt way that we're getting used to accessing information. So yes, definitely. I mean, everyone is super excited about AI, right? So we're a tech company, so obviously it's what people talk about all day. So yes. Oh, and more
Okay,
on the
I'll
way.
reach out to you
Yeah.
offline, Gustav. We can talk more.
Yeah,
This was really
I mean, the
fun.
idea is that, to make AI fly, you want to do the hard work of making data fast and accessible. That's why we're spending so much time on the API. And it's we spent maybe a silly amount of effort on this tabular controller just to make it really fast. And we started with just open, but with, open available things like Postgres and so on a few years back, but it didn't cut for what we wanted to do. So then, yeah, we have a software development team, and there's going to be a new iteration coming up as well that's going to make it even faster. So, and that's sort of with AI in mind, of course. And yeah. And my colleague, yeah, you've seen some of Joe's work is already doing vibe coding and all sort of fun things, right? So it's plenty of that going on.
I'll reach out to you offline, but just really impressive.
I'm gonna fire away my two more poll questions before you guys are off the hook. Okay, so which part of the live demo webinar was most relevant to your work? Sort of accessing data quickly on the catalog, or using your My Data space, or more on the data analysis side, and feel free to add none or nothing. Oh, sorry, all of them, or none or one.
Gustav, it doesn't look like this feature is working. I just submitted a vote and got an error message.
Oh, that's fun.
So just thought I'd tell you.
I wonder. Huh. I do see we get some we are getting some replies in, so it is working for some of you.
Okay.
Yeah. Yeah. Actually, this is fun because okay, so I can tell you, I don't know if you see the results, but quite a few are actually interested in the analysis part, and I think it speaks to this audience because I'd say the most common is that people are mostly interested in accessing data on the catalog. So I think we have a bunch of analysts on here, which is great. And I'll move over to the last question, and these are all open until we end the call. So if you think it goes too fast, it's okay. So the last questions. We are keen to collaborate to make more coral data available. And so, what's your personality, or which of the following applies to you? You know, how do you have ideas on actual coral data that could be useful? And of course, feel free to reach out to us and share that information too after the call. Would you be interested in actually joint efforts to do these kind of maps, corals or other habitat maps? We do join research proposals with a platform piece together with researchers as well to allow us to focus even more on certain topics and working together with others with a bit more funding. Would you like to use the kind of aggregated maps that I just showed in your work? or are you more interested in sort of the raw information itself? Again, multi-choice, so feel free to hit them all or none. And I do see we have quite a lot of people interested in future collaborative efforts, so that's great to hear. So again, me and Brian are happy to talk offline after this call. Great. We're actually reached the hour. I'm happy to extend it for a bit more for questions. For those
Likewise,
that want to
but
say.
we want to thank Steve for his participation in the beginning and talking about his inspiring work. But yeah, Gustav and I can remain here and answer any of your questions.
Yeah.
Yeah, thanks everyone.
But
Thanks for the invitation. That was a great demo.
thank you so much, Stephen. We know we got TNC on the hook now to discuss more about how we can make even more good use of all the great work you've done. When I was at NOAA too, I was doing quite a bit of work with TNC. You guys have been in the game for a long, long time, so very happy
Yeah,
to have you
well,
here today.
well, we'll spread this around and look forward to the collaboration.
Right.
Thanks.
Okay, I think you had to leave, Steve, on top of the hour, but if you have any more questions, feel free to voice them, and we'll spend another 5 minutes. Jennifer, go ahead.
Hi, great presentation, and thank you for all the NOAA shout outs in the presentation. It'd be interesting in the future if we could do it to maybe have you all come in and do a presentation with the U.S. Coral Reef Task Force, specifically with our state and territorial members, on how to use these visual representations of reefs in their management decisions. I think a lot of the mapping, monitoring, and tool development that we develop kind of gets a little too complex for someone to figure out a very local management decision. So the more refined we can get these maps, and especially if we're able to show changes over time, it might give the local managers a better informed way to quickly make a decision without having to collect reams of more data.
Yeah, I would love to. Let's connect, Jennifer. I think, it's funny, I didn't show that so well in the demo today, but for example, when I plotted the OBIS data, and you see how much information is around the US with all the efforts in the Caribbean, for example. And I know it doesn't even capture all of the observations because there's lots of habitat observations done, not being pushed to OBIS. And then the rest of the Caribbean is kind of empty. So there's such a wealth of information in the US, but at the same time, it is challenging to bring everything together, especially for somebody locally. Yeah, great. Thanks for that.
I think that's also like a benefit of the platform is like its ability to visualize the data on the fly, and have it be in the tabular format so that you're working with managers, practitioners, and those in the field. And also, Jennifer, I am in DC, so it's very easy for me to just bike up to Silver Spring and be in the office if anyone is actually there.
Yeah, no, there's lots of us here, and then we're getting ready to have the 51st Coral Reef Task Force meeting in Puerto Rico in about a week and a half, but we'll do a DC fall meeting. So maybe we can fold you into that and give you a little bit more exposure to the US players in coral reef conservation at the local level.
Yeah, of course. That'd be great.
Great.
All right. Any more questions before we close? Hassan.
Yes, I just have one question. First of all, it's a very interesting and inspiring presentation. My question is, to what extent does the platform support the fusion of different modalities? Like, for example, visual labels obtained from ROV or AOV transects with acoustic data layer. Does the platform support the fusion of these two modalities to produce a basic habitat map? And also, how do you validate the results, and what degrees of freedom does the user control in order to produce basic habitat maps?
Yeah, so currently, you can upload. I could have showed a bit what like, for example, sonar data looks like on the platform, but you can upload any file to the platform, and you can supply file metadata and call it through our SDKs and work with it. But the only sort of native support is for vectorized data. That's where the real power comes in at the moment. We're building out raster and gridded, and then next year, as I said, Rev Ocean is start to be operational, and so we're working a lot to make the platform, be even more customized for survey data as well. So there's going to be a progression of more tailored handling of, for example, all of the ROVs and submarine and sonar data that's going to be collected. Rev Ocean has a silly amount of sonars, for example. I think I counted to 20 in total. So we are going to be building out more like specific support for that. But otherwise, it's one place to put data to be able to access it in the cloud and do work with it.
Okay.
Yeah, so
I'm very interested in this subject because it's related to my research, like the implementation and the fusion of the different modalities. Because like different modalities have different resolution extension, and there's some incompatibility issues. So it's like how to merge them, which approach to use. So I'm very interested in that. Like I will go through the platform and read about your fusion approaches. Yeah.
great, and feel free. We also have a Slack community where it's easy to reach the technicians directly too, if there's anything very, very sort of technical that you want a quick answer to. We try to be quite responsive.
That would be
And
great.
again, kind of like I showed today, the one neat thing with the already existing aggregation features is to join vectorized data, and you can play with the sort of mapping unit and the scale problems there. But it's powerful for certain questions, at least.
Yeah, of course. Thank you very much.
Okay, great. I think with that, we close the call, and great to see so many here and quite a few friends as well. So, yeah, thank you, and reach out to us. I'll put reach out to us. The webinar is recorded if you want to go back to it later.
Thank you
See
so
you.
much, everyone. Have a wonderful rest of the week.